Hi there, everyone. I wanted to make this video going over some of the examples working with the tangent segments that we talked about in class. You're going to see a couple of examples that we already went through, and so we'll just rehash those, and then we'll see the rest. Pause this video as you're working. Make sure you're writing these down on your graphic organizer, and take the time to make sure that you can follow through, because they're going to be very similar to what some of the other problems are like. All right. So these ones we did get through all in class yesterday, but we'll re-go through them again. Sorry about that. So remember that the key here is that any tangent makes a right angle with the radius that it intersects. Okay? And so when we're looking at these figures, triangles, quadrilaterals, what we're really doing is just accounting for that 90 degrees. So in this triangle, it was the 90 degrees plus the 56 degrees plus x, and that has to add up to 180 degrees. If we combine those, we get 146, and we're just going to subtract that from 180. We have 180 degrees to use. We've already used 146 of it, so we do that subtraction, and I believe that gave us, just double checking, 34 degrees. This problem is very similar, except the x is inside of the triangle versus the outside. Nothing changes, still a triangle. We'll have 90 degrees plus this 23 plus x equals 180. So this was 113. And we subtract 113, and that gave us x equals 67 degrees. Okay? We know that with triangles, not a big deal. The difference is when we get down here, we now have a quadrilateral, and it is a kite. We did talk about that in class. Okay? But quadrilaterals add up to 4 minus 2 times 180 equals 360 degrees. And that's all that changes. We now have four angles, a 90 plus a 127 plus a 90 plus x, and that's where we equal to 360 degrees. Okay? So nothing major there, nothing all that different. When we add those up, we get 307 plus x equals 360, and x was 53 degrees. Okay? Again, we saw those in class, and we're just reviewing them. Now, depending on which section you were, we got to various parts of this. The key to these is now we're solving for sides, and we're working with the Pythagorean theorem. Okay, so you have your a squared plus b squared equals c squared, remembering that c always has to be the hypotenuse. In each of these problems, we're going to be faced with a slightly different situation. So here, we had two important steps. One, we had to realize that the hypotenuse was 9 total, the 5 here from the radius, and then the 4 that was outside of the circle. We also talked about the fact that this was also a radius, meaning that it was 5. Because this radius was 5, the radius is the same all the way around the circle. And that's what gave us that side of the triangle so that we could use the Pythagorean theorem. So I have 5 squared plus x squared equals 9 squared. Again, 9 being the 5 and the 4 together. So we've got 25 plus x squared equals 81. X squared equals 56. And I'm just going to double check what we had there. Square root 56 gave us 7.48. Nope, not 48. 7.48. Now, these two we didn't all get to in class, but they're going to follow the same concept. The key here, again, is that you have this hypotenuse that's part in the circle and part out of the circle. So we're going to combine that, except it's a variable here. So we can't just do 5 plus 4 and get 9. X plus 6 is going to become an expression. All right, so we're going to have to pull back some algebra, and honestly, we may use a little extra space here. So I might have to put a sticky note on this to get some room. But the key is we're still following the Pythagorean theorem. We just now have this expression x plus 6 to account for the entire length of the hypotenuse. Just like this was 5 plus 4, this is x plus 6. So x, and we square it. 10 is the other side, so we square it. Then we're going to look at x plus 6 quantity squared. And I'm going to pull a sticky note in over here so that you can see this. Okay. I need you to remember back from algebra, and I'm going to actually slide this over, that when I have x plus 6 squared, what that means is x plus 6 times x plus 6. Squaring means times itself. Okay. When we did that, we had a process that we called FOIL. Okay. So we did first times first, x squared, outside was 6x, inside was 6x, and last, 6 times 6 is 36. We combine our like terms, and it gave us that. Okay? This is a process you're going to see a little bit. Hopefully it's not too bad, and you remember doing that. So when I get over here, what I have is x squared plus 100 equals x squared plus 12x plus 36. And I know that there's not a lot of space there. So if you need to do this on a separate piece of paper, I would suggest that. The cool thing that happens here is that we have an x squared on both sides. If I subtract that, it just cancels out. And so really that x squared part goes away. We don't have to deal with it. What we can do then is subtract 36 from both sides. We get 64 equals 12x. Okay? And all I have to do is 64 divided by 12, which gets me 5.3 repeating. Okay? Okay? So again, pulling some of that algebra in, not a huge deal. Just want to make sure that we are making sure we're doing that right. Okay? So I'm going to pull this out here. I'm going to stick it up. Okay? But make sure you have that down. Okay? Last one in this section. We see this shape here. This is going to be a quadrilateral, a little bit tricky. But here's what we're going to do. We're going to recognize that both of these are 90-degree angles. And so what we're going to do is we're going to split this into a rectangle and a triangle. So what I'm going to do is I'm going to draw this line straight across, make that a rectangle. The key here is that in a rectangle, remember, the opposite sides are equal. So if this side was x, that means this is also x. And if this side was 5, it means that this part of the line is 5. It means this little part is 3, because the whole thing was 8. Took the 5 to make it close to that, and then the rest of that was 3. Okay. What that does, and I'll resketch this, it gives me a little triangle here. It has 3 90-degree angle, x, and 18. Okay. And that's the key here, because we're only looking for lengths. We're not looking for areas or anything like that. Okay. We can split this up. So again, opposite sides of a rectangle, are congruent. So x on this side, x on this side. 5 here, 5 here. Because this was 8, we used 5 here. That's 3 left over for this part. Okay. Pythagorean theorem works just great here. 3 squared plus x squared equals 18 squared. So 9 plus x squared equals 324. When I do 324 minus 9, I get x squared equals 315. And the square root of that is x equals 17.75. Okay. So check those out. I'm going to stop this video, and I'm going to make a second video to go through these problems over here.